Hello and welcome to another session of the Raytracer Challenge by James Buck, where I implement a raytracer in the language Rust, a language I've not used before starting to implement this raytracer. Therefore, I'm still learning all of the things and the nice things and the best practices about the language while I'm implementing this raytracer together with you. So if you want to follow along, there are all the links and resources you might need down in the description below, and you can easily grab them there and take a look at them, from the source code to the links to the book to everything else you might need. I have one thing to ask of you. If you like this, please give the video a thumbs up, and if you want to be informed when the next session comes out, please subscribe to the channel and hit the little bell besides it to get a notification when I post a new video. So now let's start. What have we done the last time? We actually implemented the last time this gradient pattern here. We are using the last sessions to implement different patterns, like this striped one here or this gradient pattern here now, where we created a gradient between red and green. And we implemented it in a way that we can define it here in our YAML as well, where I can simply tell the system that I want a pattern and that I want it of type gradient with two different colors and corresponding transformations to make it look nice, and rotate it like to be upwards and not sideways, because usually it would be sideways. And as you can see, I can easily change the color here, and the system will re-render the sphere with a different color set, which wasn't a good choice, but yeah. So this is actually quite nice. So maybe we can do a different color scheme here, something like this, for example. And yeah, as you can see, this works like it should. By the way, should you be interested in playing around with this yourself, you can simply visit this raytracer at raytracer.xyz. It will be online there. There may have been a caching problem for you should you have visited it before and you need to reload, so please do clear your browser cache before reloading the site if this feature does not work for you yet. So if it's complaining about not understanding the pattern or the gradient pattern, or not showing you this this basic rendering here once you open up the site, please simply clear your browser cache and reload again. I've hopefully fixed this for the future now, so that it shouldn't happen again and the cache is properly invalidated once you open the site. By the way, this is a compiled to WebAssembly version of the raytracer. So we are still writing the raytracer in Rust. I've just put a little bit of JavaScript and a kind of a shell around it so that we can edit stuff in the browser, and it is lively rendered using WebAssembly and the browser engine here. So essentially this is executing the same code that we are using in our and writing in our Rust raytracer. The project is open source, of course, as well. You will find it on my GitHub, or if you visit the site, there is a link up here which says GitHub link, and it will get you to this repository here. So now what are we going to do this time? This time I would like to implement another pattern, and or hopefully I want to implement more than one other pattern, because in the last sessions we needed quite some time to do this, because I hadn't done this for quite some time and I needed to get back into it. But hopefully today we will be a little bit faster. But let's start for now by implementing another pattern here, which will be a radial pattern. So we want to have, let me see if I can find an example here. Radial or ring pattern, most likely. Maybe there is a ring pattern images. No, I don't want rings. I want a ring. No, okay, that's not a good idea. Radial striped pattern, maybe something like this. No, that's not it as well. This is mostly what we are going to do. So we want kind of a pattern of concentric circles which are striped from the inside to the outside. And this is actually what we want to implement next, because it is quite, or it is mostly the same than our striped pattern here, but it's not using only the X direction, which we are using for our striped pattern. If we take a look here, so we have this striped pattern, and what we are doing here, we are only taking a look at the X position, as you can see, but for our ring pattern, we are going to do and take a look at X and Y, and therefore creating all those rings. It shouldn't be that hard to implement actually, but yeah, let's maybe get going and get started with this, simply to create something nice here. So yeah, let's first of all define the struct and call it ring. And it will, as most of our patterns yet, have two colors. So it will be striped, but in a ring manner, as you can. Oh, I've closed the tab already, but as you have seen just before. So we need color A, which is a color. Come on. And we need color B. What kind of... This is the second time that something like this happened to me. During one of those sessions, I'm writing something and it's just being removed again. And I don't know what keystroke I'm typing there. So color A and color B, which is a color as well. And of course we need a transform again, because we want to be able to transform this thing. So now we have this ring structure, and now let's copy a lot of different things we defined the last time, because we can make our life a lot easier. First of all, we need to implement default, and we implement our builder functions, and our builder functions will be mostly identical. Our fuzzy equality we can implement as well. So let's simply copy all of those here and adapt them for the ring pattern. So I will simply replace gradient with ring here, and we will see. This should actually already do it, with respect to the fact that we need certain derived trait implementations for our ring pattern, and we can actually take them from our gradient struct as well. And now this should actually already be not complaining anymore. Yes, it is working, and we have a default. Maybe for the ring pattern we should choose another color here. We could, for example, define a new color, a new base color here, which we could have named, where is it? We defined certain base color constructors the last time, and as I'm going to use it quite often, I'm defining now a yellow color here. This makes things a little bit easier. Let's directly commit that. Source canvas, add base color constructor for the color yellow. So we did this, and now we can actually use this, and let's maybe by default have yellow and blue here. And of course I could have defined the colors there by hand, by simply constructing a new color with the corresponding values, but this is nicer to read, and so why shouldn't we do this? Not much work. So the next thing we need to do is, before implementing this pattern itself, the function itself, we need to integrate this pattern into our where is it, dispatching, our static dispatching of this stencil trait. And this should actually be somewhere here. First of all, we need to check if it is, we can do it here the same, gradient should be, let's see, we should be able to just replace gradient with ring, yes. And, okay, why is this not, did I not, I did not define it. Yeah, this makes perfect sense. We of course need to add this to our struct here, which now holds this thing as well, and now we can match it. So this is only static dispatching that if we try to compare two ring patterns with each other, it knows that it needs to issue the comparison here, and I will rename this to ring. On the ring pattern. So it will deconstruct this enumeration, take the ring pattern itself out of there, the struct, and call the fuzzy equality on that. And we essentially need to do this for each of those calls to any function here, so that we can actually do this one here, and we can then propagate this. Okay, this function isn't there yet because we've not implemented the stencil trait for our ring pattern. We will do that in a second. But actually we need this stuff here to simply go ahead and dispatch to it once it is called. So let me quickly do this and rename this to ring. So we need to implement the transform function as well, which then in turn will give us the transformation that is needed from the structure. And yes, so let's go ahead and implement, where is it? Implement the stencil trait for our ring pattern. And I can tell the IDE to give us the methods there that we are going to implement, and the transform method is mostly always the same. It will simply return our transform, so that the other functions which are using, there is an implementation in the trait itself which does the transformation into our pattern space here, and it takes this transformation from the pattern and uses this. So we need to be able to return it in a generic way, and this is the way to do it. So let's go back to our stencil for ring. There we are. So now we are at color add in pattern space, and now we need to think about this. First of all, as I've said, we will need, and I'm only extracting those here for better readability in my opinion, we will just take out the X and the Y coordinate of our given position where the color is asked from, because we will need this to implement this, because now we need X and Y. So what we actually want to do, and let me maybe open up this image here, which I had reopen closed tab, because it was quite a good thing to maybe understand this. Can I make this bigger somehow? No. Okay, so but we want to, it's not exactly here what we want. We want this to be completely equal distanced, so like a stripe pattern with equal distances of 1. So the first one should have a radius of 1, and then once this distance is bigger than 1, then it gets white, and then, or it's the other color, then 1 again. So a radius of 2 will then be the other color, then we have a radius of 3, and so on and so on. And we want this to be, yes, circular, so we want equal distances from X and Y. So what we should be able to simply do is, we should be able to simply use a distance calculation for that. So let's think about this. We are calculating the distance from center. And the distance from center is actually something like the x position squared. Actually, does a floating point have a power function here? Oh, it's called power f. Okay, so let's square this one, and we add the y position squared, and then we will simply get the square root of that. So we're actually calculating Pythagoras here. So we are simply calculating the distance, the actual distance by using x and y. So it's a triangle with a 90-degree corner, so we can use Pythagoras to calculate the distance. And this is exactly what we want. And now we have the distance from center, so the coordinate is now the distance of the coordinate from the center. And once we have that, we can simply check if distance from center modulo 2, because is this actually going to work? Wait a second, do we need, no, wait a second, we cannot do a mod operation on a floating point. Let me quickly think about something. No, of course not. We have the distance from center, and now we want something like distance from center, and we can floor that actually, because we always only need the information in which kind of integer range this is. So we are always going back to the lowest integer range we are in. So if we are, for example, at 2.4, we are just going back to 2, and then we are checking if it's modulo 2. So if modulo 2, and this is 0, so if it's divisible by 2, then we are in the second iteration. So then we are not in this middle point here, but we are somewhere here. And then we are the next one and the next one and the next one. Even though this is not 100% correct, because the inner one is 0 and therefore modulo 2. So this one is 1, and therefore the calculation with mod 2 will just give us a 1. So we are actually, this one is the innermost one, that is the first one that is divisible by 2. Then this one isn't, then this one is again, this one isn't, this one is, this one isn't, this one is, this one isn't, this one is. Okay, so we actually need to simply check that, and if we are divisible by 0, we are using our color A, and otherwise, what did I do there? That was kind of strange. And otherwise, we will simply return color B. And this should actually already. Cannot mod f64 by. Oh, okay. Maybe we need to. Can we make this the right thing? No. Okay. So the problem here is that the compiler now tells us that we cannot do a modulo operation on an floating point, and this makes perfect sense. So maybe we can simply say that we want this one now, as we have floored it, so it doesn't contain a fractional part there. So we maybe can tell it that it is an 64-bit integer there, because yeah, it shouldn't be a problem. It should be, yes, that should actually work. So we should be able to store each integer value of a 64-bit floating point value inside a 64-bit integer value. Yes, that should work. So yeah, so we already now implemented our ring pattern here. So let's quickly add it to our world loader to actually use it. And we can, again, as before, reuse our logic here and call this one ring, and we will visit a ring pattern then. And now we will simply copy the definition again of our gradient pattern here, because it is mostly the same. We have again two colors. So let's visit ring pattern. And now let's check the code here. It's extracting value color A, color B. It's extracting the transforms and so on. And now from this, it needs to create not a gradient, but a ring pattern. And it's not defined in the scope, of course not, because we need to import it, but I guess I did not make it public. Yes, there's a pub missing. So now I can do, now I should be able to, yes, import this one. And the pattern from trait, did we not, I guess we forgot to implement the from to be able to create a pattern from this one. Let's see, where are our from implementation? From stripe for, yes, and we did not create a from implementation for our ring pattern here. So let's quickly change that so that we can easily encapsulate it here in our pattern static dispatch extract. So now we should be able to actually use this one. So let's go ahead and see. Let's do where are our worlds? We defined the last time something we called 3 spheres and a floor with patterns. Yes, nice. So let's take a look there, and we have now a pattern on the left sphere and on the right, on the middle sphere, but not on the right sphere. So maybe give the right sphere, or at least the right sphere has a stripe pattern, but it is a stripe pattern. So maybe we can give this one our ring pattern now, and let's what was our default? I guess our default was this one. So let's for now not do any transformations. Let's simply look how this will turn out if we simply apply this pattern. And let's go ahead and do a cargo run binary, and as always I cannot remember how this binary was named. Maybe I should just rename it chapter 09 render YAML. So we are using the chapter 09 render YAML, and we want it in release mode, and we want to render the following world, which will be 3 spheres a floor with patterns YAML. There it is. So let's quickly build the ray tracer and render this. It's by the way taking some time here, because we are always rendering a 4K images. And there we go. And either this did not work, or we did something wrong, or let's think about this. This sphere has a radius of 1. So if we do not scale anything, it will actually not have a pattern because because there is no you can actually see some rounding errors here at the gap. If you are looking really hard, then you can see that here is a pattern transition. So let's see, let's maybe transform this pattern here, and let's maybe let's not move it, but let's scale it to, let's say, 0.2 maybe. And let's re-render, and let's see. Because otherwise we will not see it, because we are only seeing one of those radial rings. So, yes, now there we are, and this looks quite a lot better. Even though I'm not 100% sure why this one is so much larger, but those seem to be okay. Maybe it's just most likely it's just an optical thing. I'm not 100% sure. yeah, but as you can see, we have our radial pattern. Let's maybe play with those values a little and see what happens there. No, I wanted to, of course, render it again. And maybe we could quickly, as we did last time, comment out the second camera to make the rendering time a little bit less. So there we are. Yeah, okay, so I'm not 100% sure that this is perfectly right, because it seems to me that this is not 100% right, even though the reasoning behind this could actually be that it is as we are taking a look at the only at the distance within the x and the y. So the most of the distance and change happening in this area here is, of course, z, because we are seeing this from the side there. So I guess what we did is right, but I hoped it would look a little bit different. Maybe let's see. Let's make this scaling a little bit different. Let's see. Just see what happens there. So yeah, no, there is something seems to be wrong in this area, because the last gap here is always, in my opinion, is too thick. I mean, this looks quite nice, but first of all, there is this kind of strange glitch here, which I don't really like. I'm not sure if this is a rounding error or what it is, but I'm kind of irritated about the way this is drawn, because optically it seems to work out until it reaches this point. So so what might this be actually? I'm not sure what this point is there. So maybe this is exactly half the sphere at this point, and therefore we are going to move back on the x into the other direction. Maybe we can see this better if we are rotating this pattern a little bit. So let's maybe rotate it around. Let's rotate it around y, and let's just rotate it around y by 45 degrees and see if this should actually rotate the pattern on the sphere this way. So we maybe see this better, but we don't. Okay, this is so let's try and rotate it in the other direction, because we are seeing the sphere from the we are seeing it from the left side. So maybe this will do its trick. Okay, so now we are seeing this strange seam there better, and I don't think this is how it should be. This kind of looks weird. It kind of looks like the pattern, which should have been created at the seam position here, should have been bigger in this direction. Even though I'm not 100% sure if this isn't what we programmed. Maybe we want to take into consideration the z value as well. And no, actually this is working as expected. What we saw here, wait, where is it? There. What we saw here is kind of the innermost circle, so this thing here, and this one of course needs to have at every of its positions I guess this is working as it should. Maybe we can, let me see. I think this is just looking kind of strange because as we are getting closer and closer to this point, the X and Y changes, so the distance changes in X and Y get a lot smaller. And therefore the stripes the rings get a lot bigger. Think of a block which has this concentric lines throughout the whole block, but in a kind of a cylinder form, because we only applied it in a 2D form. And then we just cut out a sphere from this block, and then this will be the result. And it makes perfect sense, because once we are going to get into this region here, we will kind of be stuck in one of the blue layers here, because we are not changing much anymore in sense of the diameter of the sphere. And the farther we go along, the smaller the diameter gets, and then it will get into another of those yellow rings again. So this is actually the correct output, even though I would have liked something a little bit different optically, but this is the pattern we implemented. Maybe we can do another pattern here this session quickly. I hope, even though we are already in 40 minutes again. But maybe we should create another one. So we had the concept of a 3D pattern there. Maybe we should implement one. So maybe we should implement a 3D checkerboard pattern. Let's see, are there any images for that? There are of course images for checkerboard, but checkerboard 3D pattern. Yeah, we want something like this as a pattern here. So we want a 3-dimensional checkerboard pattern. Yeah. So we do not only want it in 2 dimensions, but we want it in 3. And if we are implementing this one, we don't need the 2D one, because, for example, we could lay it on the plane and it will be a checkerboard pattern, because the plane is only 2D. But if we want it in 3D, if we want it, for example, for a cube, like this one here, we would actually have this nice pattern as well in 3D. So we would like to implement this one. So what we need to do there is, of course, again, let's do a pub struct checkerboard 3D, maybe. Yeah. And yeah, we need 2 colors again, the old thing here. So we need, what did I do there? Color. Let me scroll this up a little. And we need color B, which is a color as well. And we need our transform there, which is a matrix with 4 components. By the way, if you are wondering why we are using 4-component vectors and 4-component matrices, even though we are only in a 3D world, I've recently done a video about this, which you can find on my channel to explain in quite simple terms and with a simple example why we need 4x4 matrices and 4-component vectors. So yeah, so now we have this. Come on, we can again copy all of this. We can first of all copy the derivement of the different traits we need. Then we can go ahead and copy all of this initialization and fuzzy equality stuff here, which is quite neat. Maybe we should get or create a macro for that, but I'm not 100% sure how I would do that, because there might be a pattern in the future. Even though all of those patterns we've implemented use 2 colors, there may be one which needs 3 or 4 or 6 or something completely different, and then our macro wouldn't work anymore. But yeah, maybe we could simply clean this up a little. I will maybe take a shot at this. I don't know, maybe off camera, maybe on camera. We will see. Tell me if you want to see some kind of refactoring regarding this with a macro or stuff like that. And I will happily do it. So yeah, so we need to replace ring in this case with, how did I call it? Checkerboard 3D. There we go. So then we have this, and we of course need our implementation here. Let's call it Checkerboard 3D, and there is a Checkerboard 3D in there. And then we of course need to match this up. So let's replace ring with checkerboard here, and let's call this parameter not ring but checkerboard. And there we go. And then we need of course a match here, and we will replace this. Come on. We'll replace this as well, and we will call this Checkerboard as well. The transformation of course needs to be dispatched as well, and this will be checkerboard as well. Yeah, those methods cannot be found yet, and we need a from implementation on the pattern. If it is given something of the type checkerboard 3D, then it is taking it and it is creating the corresponding checkerboard 3D enumeration type there. So let's reformat the file. Okay, so of course those methods are still missing because we have not implemented them yet. So let's see, let's implement stencil for checkerboard 3D. And let's have the IDE do some of the heavy lifting for us by defining those types. And let's, of course, first implement the transform function, which simply returns transform. There we go. So now we need to think about how we would implement this checkerboard. Actually, in order to implement this checkerboard pattern, let's first think about a two-dimensional checkerboard pattern. So where is it? So only think about this structure on top. So, and this would be the X and this would be the Y axis. So what we want to do is we want to iterate the color on the X axis every 1. So here is from 0 to 1, then from 1 to 2, from 2 to 3, from 3 to 4, and so on. Iterate it. And on Y, we would like to do the same thing. We would iterate on each step of Y. So does this sound kind of familiar to you? This is actually a striped pattern, but in 2 dimensions. We are not only taking a look at the X, but at the Y as well. So this is quite simple actually. If we take a look at our stripe pattern, how we implemented this one, it simply was we took a look at the X value here and we simply did a modulo 2, so to see if it's iterating between the different values, as we have done here many times. And then on this basis we decided if we would put a color A or a color B there. So we could actually do this now, not only with X, but with Y as well. So if we went there and were using the value of the X value here plus the value of the Y, then we would be in this 2-dimensional checkerboard here. So if we have those 2 values together, and we calculate those, we calculate the floor values of those, because we with each step in each axis, regardless, we want to switch. We are just adding those up. So we would have something like, let me get the X out here again, position X, and let Y, position Y. And now we would do something like if, let's see, if X floor plus, come on, y floor, and yeah, we need as, what did I do before? 64. Might be that we need to put parentheses around this. If this modulo 2 is 0, we want to return self color A. No semicolon at the end. Come on. And else we want to return self color B. This would actually be a two-dimensional checkerboard pattern. And as we now have the Z component in here as well, we can simply add it as well. So we now have the differentiation here in each of the coordinates, so that we always have this thing here. If any of those coordinates goes beyond the next full integer value there, we will flip the color. And this is actually exactly what we want here. Every time one of those coordinates goes around to the next full integer, it's completely irrelevant which one. If any of those flips to the next one, we want to change the color value. We want to go to the other color value. And for example, as you can see, if both of those flip, like for example, we are here inside the second one in X, and we are down here, the second one in Z as well, then we, of course, as you can see, want to flip 2 times. We want to flip this one to black here and this one again to white, and then we have white again. So adding up those values is exactly what we want to do there. Let's quickly check if this looks as we expect it to. So let's copy again our pattern visitation function here. Maybe we can do something about this in the future as well, to maybe reuse some more of this code, even though it's just identical because the structures are identical. They don't have to be identical. So with the visit checkerboard pattern, I guess I call this simply checkerboard pattern here and not checkerboard 3D, because we will only have one of those and we actually don't need to. Maybe I should have called it checkerboard. Let's call it checkerboard 3D, and we can change this in the future if we don't like the naming. So we have now this function here. So we have visit gradient pattern. There is the thing where we need to add it now. Let's call this one checkerboard, and we will do a checkerboard pattern. We will visit this one there, so this should work as well. And maybe now we should be able to see this quite nicely if we apply this to the floor. So let's maybe put it on the floor here, like let's do a checkerboard here, and let's see what happens if we simply do a black and white checkerboard pattern on the floor. And another thing I'm thinking about here right now is, what did we do in terms of default value? I know that we copied those, but do they make sense? No, they do not make sense, because for the checkerboard pattern I would prefer black and white checkerboard by default. So okay, so let's go ahead and try and render this, and let's see how this looks. If we have now a checkerboard pattern on the floor, and if I've told the truth about that, or how easy it would be to implement this. I hope I'm right. Yes, and as you can see, now we have a checkerboard pattern on the floor. But this checkerboard pattern actually is only in 2 dimensions, isn't it? Because the it is a plane, and the plane is flat. The plane doesn't have a thickness in Z. So, yeah, it kind of does. It doesn't have a thickness in Y here actually. But yeah, we let's not think about this at the moment. But we have a checkerboard pattern here. That's quite nice. And what would happen if we, for example, instead of giving this one a striped one, give this sphere a checkerboard pattern? And it will, I can tell you, it will look different than what you might expect it to look like. So maybe we can, for now, remove the rotation, because I guess this will look kind of strange, even though it might look cool. Yeah, let's give the middle sphere a checkerboard pattern, and then you will see what I mean. And this looks kind of strange. It looks cool, but it looks wrong a little bit, at least. But if you think about it again, if you would have a block, it's the same thing as with this one. If you would have a block of massive checkerboard pattern, a square block of checkerboard pattern, which is through and through checkerboard pattern colored, and you would cut out this sphere from this block, then you would actually get exactly this optical representation, because the checkerboard pattern is not kind of lying on the outside of the sphere, but it is the complete structure of the sphere. It's going through and through to the sphere, and we are only cutting away all the material that is not there, and this will be the result. If we would like to have it like we want the checkerboard projected onto the outside of the sphere, we would need to implement something like texture projection and stuff like that. And we might even do this in the future. I'm not 100% sure when and where, but I think I will implement texturing at some point, and then we will get into this again, and maybe then we can lay around the sphere a checkerboard pattern, which would be quite cool actually. But this one actually is the cutout of a checkerboard patterned material. And this is actually what we implemented there. We implement the coloring of the material, so the whole thing, and not of a specific hull of an object. Yeah, so that's actually quite nice. So we did our second pattern there, which I know looks right at this point, even though with this one I wasn't sure, so we had to experiment around with it. And I could even now add the rotation again, and it should look quite fancy now if we put it in there like this. I'm not 100% sure if I want to, but we could actually. So yeah, and as you can see, this kind of looks a little bit trippy, but yeah, it's kind of nice. So let me maybe let me maybe not do this to the sphere here. So let's start with this one. Yes, we want this one on this should be the floor actually, and we want it there, but we don't want it on the middle sphere, and we don't comment out the camera. So exactly, and then we would add source patterns rs. Yes, we want this. No. I don't want this to be checkerboard 3D. Let me simply call this checkerboard. So yes, I like this more. So it should have automatically been updated here. Yes, because we only will have one of those. We will not create a 2D version of it, because why should we? So this is something that he didn't rename automatically, because it is a name that is essentially not bound to the same object, so he couldn't know. But now it should be, yes, that's the definition, that's the, yes, fuzzy equality, yes, that's the implementation of the from, that is our implementation of the checkerboard pattern itself, and there we go. So let's source world loader and so on. Yes, import, yes, visit, and the visit function itself. And what are we missing? We already had the part of that edit, so let's commit this. Implement 3D checkerboard pattern. Be aware that patterns are not textures. You always need to think about patterns as a way to color a block of full material where the part of our geometry is cut out. This does explain why a checkerboarded sphere actually looks a little weird. So let's get back our, now let's go back to the one that we have with only the checkerboarded, checkerboarded floor. Let's render this again. And by the way, I will quickly show you what happens if I only apply a 2D checkerboard pattern to a sphere, because that actually looks more than what you would expect. It isn't perfect, but it is more than what you would expect. Yeah, now we have a checkerboarded pattern and we have everything else patterned here. That's nice. So checkerboarded floor. And now what if I'm going ahead and changing this one? Let me quickly, simply to show you, and this gives me to think if we want a 2D checkerboard pattern as well now, even though I've just renamed everything and told you that we wouldn't want one. If I only do this in X and Y and not in Z, let's see what happens then, because this will look a little bit more like what you would expect if the it's projected to the hull. It isn't, of course, because it has the same problems or the same difference where it is not projected onto the main area of this. But no, yeah, I did remove it from the sphere, so I need to put it back again on the sphere. So let's do where is it? There. Let's do a checkerboard here. And the floor, of course, isn't checkerboarded anymore now, because, as I've said, we are not doing the Y with regards to the floor. So it's not checkerboarded then. We would have needed this then in X and Z checkerboarded, and this would then work. But now, as you can see, this kind of looks more like what you would expect, because now you have this checkerboard which goes through the sphere, through this material, only in 2D. So a massive block which only is checkerboarded in 2D and then just goes through there, not in 3 dimensions. And then we cut this sphere out, and this looks a little bit more what we would expect, but it's not right, because if it would have been right, then the checkerboard at the edges would need to be a lot more stretched, because it's going around. If you would have put a texture on it and projected it, then this one would need to stretch around the edges, because you are seeing it, and it's a very tiny amount of Z that it's going around there, and it should look different. It should look stretched. But I'm now actually really thinking about if I want a checkerboard in 2D only to be able to render something like this, because I think it's cool, even though it's not projected, but it's a 2D checkerboard, and I would like that. Damn. Okay, so now we will have checkerboard and checkerboard 3D, and damn it. Okay, so let's maybe do this and have the floor as a checkerboard 3D, and this one as a. Then I would say that we specifically name this checkerboard 2D. Not sure. Or is this just checkerboard and the other one 3D? Or do we even want the same? Oh, we could. Nice one. We could introduce. I have an idea. Why not introduce another option here? So allow us to do a checkerboard, and we specify the axis in which it should checkerboard something. So we are simply saying axis now here. Maybe. Third dimension is a Boolean. I will simply allow the switch between
3D and 2D and not the possibility to define axes, even though that makes it a little bit less flexible. But we can think about this in the future, because I don't want to have this much change and stuff there now, because third dimension is by default true. So we have now with color, we need, where were we there with transform? Let's copy this one, and this one will then be with third dimension, and we are getting a third dimension, which is a boolean here, and it will set third dimension to third dimension. And so now we should be able to set this one, and of course we need to add, not to remove something there, but to add a check about the third dimension, which yes, there we can directly do a third dimension, because fuzzy equality on bool doesn't make sense. So let's put that last. And now let's see, if we are here, we will see, we will have this if self dot third dimension, or better, yeah, as if self third dimension, and this one here, which I need to I guess need to put parentheses at different positions then, because wait, we need to have this here as this one, yes, and there we need this one, or self dot, and there we need of course the third dimension then, floor, and if third dimension is not set, then we only want to check x dot floor plus y dot floor, and we need this as an I64 modulo 2 equals 0. So if third dimension is set, we are comparing all, and if third dimension is not, then we are only checking x and y. Okay, so this should actually work. Now we need a way to define this. So our YAML parser now needs to read this, I guess. So when we are visiting our checkerboard pattern, let's see, we should actually check if pattern hash contains key yeah, let's call it third dimension, or can we call it 3D? I guess we can call it 3D. Makes kind of more sense. So if this pattern hash, if the key is there, then we will of course read it. So let third dimension value equal self get value from hash pattern hash 3D. And we need a shortcut if we can't get it. And then we do a self path push seg. Do we even need that? Couldn't we? Wait a second. Don't we have a self get something like get something from something. Don't we have, I guess we have such a function there, something like we can get floats and something like this directly, I guess. I'm not 100% sure, but I think get value from hash, get index from array, value to string, hash value to string, there we are. Value to int, hash value to int, value to float. Do we have something like to boolean? We don't, because we don't have bool flags yet. Interesting. So maybe we should add something like a bool flag there. So let's see. Let's maybe copy something like hash to value string, and let's maybe add this one below all of this, value to float, hash value to array, value to hash there. Okay, so hash value to bool. Of course, that would actually make life for us a little bit easy. So we are getting a hash, we are getting a key, and then we are returning something that is a bool. And I guess we don't need the lifetime specifier there then, because a bool is a value that can actually easily be copied. So with a string can't be copied this easily. Well, it could be copied, but we don't want to clone or copy it, because we simply want to have a reference to it. So yes, this is actually the pass pushing there, then get value from hash. Then we are, what is the problem here? At reference, did I guess I removed the hash on the reference there unintentionally while I was removing the lifetime specifier. So the result would be yes, and we would need to implement then this as well. So let's copy the value to, or first of all, let's value to bool, and then we are returning the result, and now we need something like the value to string thingy here, and we need to adapt it to work with a bool, to do all the nice error checking there. Value to bool, and we would get a reference to a YAML there, and we would return a parser result with a bool, because we could fail. So, and I guess this one was, is there a YAML boolean? There is a boolean. This is nice. I like that. So expected bool found reference to bool. Okay, so we just dereference this one here. Okay, so expected boolean value at the position in the path, but found. Okay, so this is good. Hash value to bool. Okay, of course those values are not, those functions are not used yet, but we will use them in a second. So let's just do get value from hash. So the function was get. Okay, let me comment this one, and this one was get, or was it a hash value to bool, I guess, and we are putting in the pattern hash, and we are putting in the key, maybe? What does it cry out about? The key was 3D, wasn't it? So hash value to bool, cannot find function hash value to bool. How did we name this one? Hash value to hash value to bool, hash value to bool. We actually, that's kind of strange. Why is it not? We are using those, aren't we? Wait a second. This is, of course, I'm a little bit stupid there. This is not a function. It is defined on our parser there. So hash value to bool. Yeah, no, the train bound as a string is not satisfied. What, as a string? What did I do? Hash value to bool. I have something done horribly wrong here. Oh. Yeah, okay, I see. So we are not using this key macro there. We are simply specifying this as a string there. And now we have this value there, and then we can do and if it's not there, wait a second, we are doing it like this. We are saying let third dimension value equals true. So by default, it will be true. And we will call this with a shortcut so that it should actually be okay, let's just define this here, and then let's do the default here. That makes things even clearer. So if it's not defined, it's the value that we were given, otherwise it's true. And now we need to create this one with our, come on, corresponding with third dimension. Why? What? Yes, so, and it's third dimension shouldn't have been called third dimension value, it should have been called third dimension, so let's do this. Yeah, so now this should actually be created the way we want it to. Let's check if it really does. So, in case of the floor, we are just doing a checkerboard pattern here, and in case of the middle sphere, we are doing a checkerboard, and we are saying 3D is false, because we don't want 3D. We don't want a 3D checkerboard pattern. We want only a 2D. So let's render this and let's see if this works or if it crashes or panics or whatever. Because I guess it should actually work. That would be nice, so that we have both options there. So open main camera. Yeah, and as you can see now, this actually works. We have the 2D checkerboard pattern on the sphere, and we have the 3D on the floor, because otherwise we would not see this correctly, or we would only see a striped floor there, because we are doing this one in the X and Z direction, and otherwise it would only be X and Y. So yeah, that's kind of a neat result. I like that. So maybe I will let me copy 3 spheres and the floor with checkerboard patterns YAML to a specific well, it's 3 spheres and the floor with patterns, yes, and let's add source. Or did we do something else there just to make sure? Yes, we added this one, we added this one, and we added this one, and we added this one. Yes, that's okay as well. So, okay. And so we can add this one there. And we should change, the camera is already in place again. So let's add this one. And let's commit this. Made checkerboard pattern either 3D or 2D by configuration. Yes, and so we have that. So we can now check out the original pattern definition here we had, so that this works out as well. Yeah, so we implemented 2 patterns today, and we made one of those even more configurable than I originally planned, and we even made, or technically we implemented 3 patterns because we did a 2D and a 3D checkerboard pattern, even though I hadn't planned to do a 2D one, but I like the look of it. So I still like the outcome of this, and yeah, I will of course rebuild the REPL as well and release a new version. So if you want to play around with this, you will be able, once this video is out, to visit raytracer.xyz in your browser and just play around with the definitions you've seen here to change the YAML file and to render something like this. I hope you had as much fun as I'm always having implementing this ray tracer. Please check out the source code if you like. Comment on YouTube videos. I will try and answer all your comments, or answer them either in comments or in the video. If you see any problems, bugs, or anything else, please open up an issue on GitHub, or comment on the video, or contact me in any other way. On Twitter, for example, I'm there. If you liked the video, give it a thumbs up, please. And yeah, if you haven't done so already, please subscribe and hit the bell right next to the subscribe button to be informed once a new video is out. Yeah, I hope to see you in the next one. Bye.